So today's lecture we will discuss about divergence and curl of a vector field. So this is the fifth lecture of module 1, and let me define what is a vector field. So a vector field is in a plane, that means two-dimensional surface, is a function that associates with each point P in the plane. That means for each point P in the plane, a unique vector f of p parallel to the plane. So for each point, we will associate with a unique vector. Then we say that it is a vector field. Similarly, in three-dimensional space, is a function. A vector field is a function that associates with each point p in 3 space with a unique vector. That is, if this is a 3D space, any point p in 3D space, if we associate with a vector, then we call that field as a vector field. For example, if we consider water flowing through a stream, and if we are taking the first layer of water, each point of water, that means each molecule or each point, we can consider take the velocity at that point. Okay, so then for each point there will be a velocity, and we will associate each point with that velocity. Then that field is also a vector field. Okay, so that means velocity of a water flowing uh, through the stream is an example for real life example for vector field. So or we can consider the force field is also a vector field. So now I will define what is gradient field. So this is an example for uh, vector field, and we find how to find a gradient of a scalar function. So gradient is a vector function vector. So recall that if phi is a function of three variables, that is, suppose phi is a function of three variables, phi of x, y, z, then the gradient of phi is defined as del f is dou phi by dou x I plus dou phi by dou y j plus dou phi by dou z k. If it is a two variable function, then del phi is simply dou phi by dou x I plus dou phi by dou y j. So this field for each point x, y, z, del phi is a vector field because it's a vector. Now I define what is conservative fields and a potential function. So a vector field in two space or three space is said to be conservative in a region. Is said to be conservative in a region if if it is the gradient of for some function phi in that region. That means if this vector f is a gradient of some function phi, that is f equal to del phi, then we say that this function vector field is a conservative vector field or conservative, and this function phi, scalar function phi, is called a potential function. For example, if I am taking phi of xy equal to xy is a scalar function, and if our function is yi plus xj, if this is my vector field, then clearly f equal to del phi, right? Because del phi is actually dou by dou x of xy I plus dou by dou y of xy j. So this is simply equal to yi plus xj. So clearly f equal to del phi. So this is an example for conservative vector field, and here This phi is called a potential function. This conservative vector field has importance in line integral. Okay, so we will discuss those things in while we are integrating vector field. Okay. Now there is an important concept called divergence and curl, and this is very important for in fluid mechanics, fluid dynamics, etc. Because it's mostly related with the fluid flow. Okay, that means inward or outward flow of a fluid. Basically, says divergence and curl of a vector field. Okay. So, if you have any doubt, you can ask me. Now, in this lecture, we will discuss how to find out divergence and curl of a vector field. So, the definition of divergence is if this is a vector field f of x, y, z equal to f of x, y, z, I, g of x, y, z, j, h of x, y, z, k, then we define divergence of f is denoted by div f is div f equal to dou f by dou x plus dou g by dou y dou h by dou z. So this is actually a scalar field. Okay. So divergence of a vector field is a scalar field. So this is not a vector scalar. So this is very easy. So this is the formula for finding divergence. Next we will find a formula for finding curl. So curl is f of xyz is equal to f of xyz I plus g of xyz j plus h of xyz k. Then we define the curl of f uh, to be a vector field given by curl of f is dou h by dou y equal to minus dou g by dou z I dou f by dou z minus dou h by dou x g dou g by dou x minus dou f by dou y k. So there is an easy formula for finding this. This is simply curl f or a curl f equal to this is actually del cross f. So del function is we will define dou x dou by dou xi dou by dou yj dou by dou zk. This is an operator. So if this is the determinant of this, so this is simply if we are taking the determinant, we will get this. Okay. So this is very easy to find curl and divergence of a vector field. Now we will do a problem. Find divergence and curl of a vector field f of x, y, z equal to x square y I plus y 2y cubed z j plus 3z k. Solution. Tell me okay before that what is the formula for finding divergence? Div f is equal to dou f by dou x plus dou g by dou y plus dou z by sorry dou h by dou z. That means this ith coordinate if we differentiate with the x and this with respect to y and this with respect to z. That is div f is dou by dou x of x square y. This is our f. Okay. Plus dou by dou y 2y cube z plus dou by dou z 3z. Okay. Now if you differentiate this, this is differentiating with respect to x, we will get 2x y. If we differentiate this with respect to y, then x and z are constant. So 6y square z, and we are differentiating with respect to z. That is equal to. So that is the divergence of this vector field. Now next we have to find out curl f. So actually this divergence is del dot f and curl is del cross f. So del dot f means del is actually dou by dou xi plus dou by dou yj plus dou by dou z. Okay, that is del. Dot f means dot product of this f. So if we find the dot product, we will get this. Right? Now curl is del cross f, cross product of del. So this is simply okay. We can do here I into we remove this dou by dou y of 3z minus dou by dou z of 2y cube z minus j times we remove this dou by dou x of 3z minus dou by dou dou z of x square y plus k times we remove this dou by dou x of 2y cube z minus dou by dou y of x square y. So if we differentiate this, we will get, so this is the derivative. So this will become 0 because z is a constant. We are differentiating with respect to y, z is constant 0 and 3y square z, and we are differentiating with respect to z. This is a constant, so this becomes 0, and here we are differentiating with respect to x. Z is a constant, this becomes 0, and here we are differentiating with respect to x. This is 0 and this is x square y. So this is curl x. Curl. Any doubt? So this is your do this problem and tell me the answer. Find divergence and curl of this vector field.